hundreds of millions of people suffer from diabetes globally, creating huge economic challenges for health systems and strain on families. Scientists like Dr. Seung Kim at Stanford are hoping to reduce that impact.
My name is Seung Kim, and I'm a professor at Stanford University, and I also run a lab here of about 14 people.
The Kim lab studies the pancreas, the organ that controls blood sugar. Cells in the pancreas release insulin into the blood after a meal, allowing sugar to enter the cells that need it as fuel. Patients with type 1 diabetes have dysfunctional pancreatic cells, forcing them to calculate and inject the insulin they need, a marvel of biology that the rest of us do with no conscious effort. But even for patients who manage their blood sugar with cutting-edge hardware and software, diabetes still poses a burden.
My mom noticed the symptoms of being thirsty, and she tested my finger, and she was like, yep, you have diabetes.
I think one of the biggest burdens is just that he has to bolus before he eats.
For example, during lunch at school, it's hard to remember to take it out.
To have to look at his lunch tray, figure out how many carbs are on it, to type into his phone what his lunch bolus should be.
And for many patients, constantly replacing injection sites and pumps becomes expensive, annoying, and raises risks of complications. That's where Dr. Kim comes back in.
We think that the best device for delivering insulin are the cells that actually know how to do that, and the beta cell is exquisitely tuned to controlling a very tight range of glucose. No device can do that, but the cell can.
For the last few decades, rodent models have been the main way scientists have studied pancreatic function and dysfunction, but these haven't translated into successful human trials.
We've cured diabetes in rodents, I think hundreds of times at this point. It's just not that close to what humans are.
So the Kim lab turned to pigs as models for human disease. They have strikingly similar anatomy and physiology, to the point that we already use pig parts to treat humans.
One example are pig heart valves, which have long been the basis for valve replacement in humans. That speaks to the similarities in terms of form and function.
Having a more realistic model of pancreatic function and disease will be essential if scientists hope to make progress on cell-based therapy. But it goes even further. Could pig pancreas cells help coax dysfunctional human ones back into action?
Whether or not that's in a culture dish that involves taking fetal islets and using those to provide cues to the human cells, or whether it involves actually putting human cells in pigs and letting them mature there and then retrieving them for replacement in humans.
Luckily, Stanford's Discovery Innovation Fund exists for exactly these scenarios. A small amount of money to a top researcher to explore an outside-the-box approach. If the preliminary data is promising, it opens up access to larger grants from external funders. Dr. Kim got the award in 2016, and it's already paid off.
Now we're publishing the first paper on pig islet development, and we just got news today that the journal we're publishing in is so excited they want to highlight it. So with that, then, we are now able to go and compete for funding.
With improved models and new streams of funding, the promise of cell-based therapy is getting closer. Could future patients live without the constant stress and strain of having to externally control their insulin levels?
I'm not sure about a cure, but I hope to not have to think about it so much.
To just eat randomly and have your blood sugars be perfect? Can't imagine. But it would be amazing.
Whatever the solution is, we know that more research, more funding, and better models provide the best chance we have to get there.